are in listen-only mode.
Good afternoon, everyone. This is Stephen Jackson from Imprintables Warehouse, and I want to thank you for taking a little time out and spending it with me this afternoon to go over color for print processes, where we're going to talk about color and how it works and the theories behind it, and ultimately how you can make some changes in the processes that you're doing right now with whatever device that you're using currently and produce better results for you and your customers. So we're going to go through all that today. And we've got a few questions. I always like to do the questions right off the bat so we get them done and out of the way. And we'll be bringing up the first one now, I think. And do you currently offer wide format printing? This is anything over a desktop printer. We're not looking in this one here for if you've got an inkjet printer that you're doing desktop level stuff, even 11 by 17. We're looking at anything from like a 20-inch BN20 all the way up to the real large format ones. That was a quick poll. Well, there's only a few people here. So yes, we got 43% and no 57%. So those of you with the 57%, I suspect some of you may be direct to garment. And some of this does apply to the inkjet printing too for the desktop printers. Next question coming up. Do you currently offer sublimation printing? And this pretty straightforward again, yes or no. Any of the different sublimation printers out there, whether you're using like a Ricoh with the gel inks or Sawgrass inks or anything like that, any type of sublimation, and even if you get it from another person. And 67% of you, yes, and 33% no. So with sublimation, all this correlates into it also. There is a little bit different process that you're working with, but we'll go over that. Next question, do you currently offer direct-to-garment? And you guys are getting the picture probably now that we're trying to figure out what you guys are using for the, and what you want to learn more about for color management. So all these questions help us to develop future webinars also. And that result is coming up right now. And no, 78%, and yes, 22%. I actually expected this one to be a little bit higher, but that's an interesting number for us. So I don't remember if there was a fourth one or not.
Nope.
Okay, so that was all for the questions, and now we can get into the meat and potatoes of the lecture, which I'm sure everybody is really here for. So what is color? When we talk about color, you have to have, it's an event. Somebody once told me that it's an experience that you have to have. You have to have three components to make color work. And out of those three components, we're going to have light. So a light source, that could be anything from an incandescent light bulb in your house to the fluorescent lighting in a shop, any type of lighting source, the sun when you're outside, or even moonlight. But you have to have some sort of light. Light is very important in this whole process because how much light we get in the source of the light can also change that color, and we'll get into that. The next one is we have to have an object. It has to have that light hitting that object so that we can have color come off of that. So the object in this one is just a nice fall foliage scene. I thought it was kind of appropriate for this time of year. And last but not least, we have to have an observer, somebody who's going to receive that light and be able to interpret what it is. The observer could also be something like a spectrophotometer, which is this changing on there? I'm going to back up here because I see there was a little issue. So let me back up because you guys weren't seeing anything. Okay, what is color? We said it's an event that consists of three different players, the light, our object, which is the fall foliage, and you guys should be seeing this now. Hopefully, Jody, if you got any remarks on that they're not seeing in the update, that it's working now. And then the observer, whatever's going to see it. And the first observer is a person here. The second thing in the observer could be a spectrophotometer. A spectrophotometer is a device that measures wavelengths of light, and it's kind of independent of what the person would be. So if we had a person with, say, a color deficiency, that spectrophotometer doesn't have any color deficiency, and we can measure light appropriately. So when we talk about the object itself, the object absorbs and reflects light, and what is reflected is seen by the observer. What we mean by this is, as that light comes in and it hits that object, say it's that scene of all the foliage and everything there, it's reflecting off of the water, it's reflecting off of the trees and everything, it's got to be partially absorbed and partially reflected. What is reflected is what we can see as a different color, and what is absorbed is removed from the spectrum on there. And then again, the observer. But in this one, the more important portion is the object, and we'll get in a little bit more to that too. The observer, let's get this going. We have the light, we have the object, and the observer. Every observer is different. So if I have an observer that is, like I said, colorblind, we would not be talking the same language. So if somebody comes into my shop and they say, I want this print to be in red. Well, what's red to them? Is red a fire engine red? Are we talking Coca-Cola red? Am I talking a brick red? Whatever that red may be, that person might observe it differently. If we have two people in the shop and one of them is colorblind on red and they start talking about that color, well, obviously they're not seeing it the same way as I am. So every observer is a little bit different, and we need to take that into consideration, and it leads to subjectivity, where your customer may not be speaking the same language as you on this. And we need to make sure that we can come up with some sort of uniform way that everybody can have the same color and be talking about the same color. Color management does this for us. It removes that subjectivity. So having a properly calibrated machine or properly set up a color management workflow using a spectrophotometer to measure that color, or as we're going to show later on, using certain charts to make sure that we're all using the same color, it removes that subjectivity to where when we start talking the same language on it, where maybe I'm using a lab value or a Pantone color, which most people are familiar with, if they say that they're going to use Pantone 431C, then we're all speaking the same language. So what is color? Color itself is different wavelengths of light that can be perceived by the human eye. Everybody's probably heard of Roy G. Biv. That's taking a spectrum of light and turning it from prism and a rainbow. And you can see the little prism over here. I've got it there, and it's got all the different colors. And Roy G. Biv is red, orange, yellow, green, blue, indigo, and violet. And so we've got the different colors in the spectrum there. And it's, like I said, it can be subjective, affected by color blindness. And surrounding colors, which I've got something coming up here that you'll be able to see the surrounding colors and how it can change on that. The light source itself, we hit on that a little bit earlier, but anybody who's been to Home Depot and has seen the wall of color when you're picking out a paint or something like that knows that you have to go to the proper light source to see it correctly. They've got that little lamp that's over at the table that you take that swatch of color over to and you stick it under there so you can see the different color and how it's affected by the lighting. If I'm using fluorescent lighting and then I go outside with that color, it can shift quite a bit in there because of the light source. What we measure a lot of our colors by is what's called D50. It's a standard light source, and it's considered daylight level or daylight warmth of light. Whereas when I'm working with fluorescent lighting, it's a very yellowish color. Jody, I don't know if you're still online right now, but I think your mic is still on. I can hear you in the background typing away there.
Oh, I'm sorry.
That's okay. So the light source can change this quite a bit there. And then next on there is texture or substrate. So if I'm, say, talking about a matte finish or a glossy finish, or if I've got a textured wall or a textured object, like, say, a garment, that can change the way that it's perceived as well, because the color can shift with that texture where it's got nooks and crannies it goes into. So you have to take all that into consideration. And the last one on this white point or of the device or the substrate itself, this one's very important too, especially for those of you out there that are doing sublimation, which we saw in quite a few of you on the survey there. You may print out something, but whatever we're heat pressing onto for that sublimation, how bright a white point on it will definitely affect the outcome of those colors. If I have a dull white, say like just a regular writing paper, and it's got kind of a dull white, it's not a real bright glossy white finish, my colors are going to look more dull. And anybody who's done sublimation on, say, like a light gray shirt or something like that and seen color shifts understands that pretty quickly. This occurs with anything that we print onto, including direct-to-garment printers, any of the digital print devices, say like a roll and Versacam or anything in that category, we're printing onto some sort of substrate, so that white point is going to affect it quite a bit on the end result. And that's taken into consideration when we talk a little bit later in the lecture about profiles and how profiles are created, and we take that white point into consideration. So next, we talked about how subjective color can be and by the surrounding colors. This is what's called a Purvis cube. And if you take a look at it, the color in the middle side and middle top, we're talking this one right here, and then the one down below in the center where it looks kind of yellowish. Let me highlight these for you guys. So we've got this one down here. That highlight didn't really highlight it very well. And up top, let's change the color if I can so you guys can see it. We'll do the spotlight, see if that does it. This one here, and then the one down in here. If we take a look at those look like they're two different colors, when in fact, once I come in, and I'll erase all drawings there, and turn that highlight off, sorry about that. I'll start moving in this little cover here, and I'm not changing anything at all in the graphic, and once that covers up those two areas, you can see they're both actually brown. They're the same exact color. So let me back that up for you for a second. So you can see how this one on top and this one on the side look entirely different. That's because your eye is deceived. You can see all the colors around that, and it's affected by it. If anybody's ever had a design that they've done for a customer, and they get done with it, and they print it out, and the customer says, hey, that's not the color that I specified. That's not the color I picked out from your chart. Simply take your hands and collapse your hands around it so you're covering it. So we created, so it's kind of like this Purvis cube, so it blocks all the surrounding colors, and they can see, actually, yes, it is the color that you picked, and we hit the right one, but your eye is fooled. It's deceived by the colors around it. So color can be very, very subjective based on the substrate, the surrounding colors, light source, so many different things can affect it. And also, not to forget the person who's looking at it. So we're going to talk a little bit about color spaces. And one that's thrown out there a lot that, well, I shouldn't say a lot, one that's very critical to everything we do, but most people don't know about is lab. All digital devices read color in lab values. And what lab is it's a measurement of the lightness of white to black. And we can see it going up and down there in the center, white to black. And then the A value would be green to magenta, and blue is B is blue to yellow. This gives us a scientific value for light, or for color. And anytime I'm talking to somebody, I can go lab value to lab value. So if I send this over to somebody, say in China, and they're reproducing something for me, and I say this is the lab value of it, they can match that exact lab value. Now, there's going to be some processes after that to get an output from whatever device they are, but we are speaking the same exact language, and we know exactly what that color is because it's defined by a scientific value. So that's lab. Here's a couple of the different gamuts, and we're going to touch on gamut a little bit later on and discuss what that is, but you can see in here, there's the lab value. It's the big one off to the left here. It's got all the different colors in it and everything, and you can see the different areas in there. There's Adobe RGB, sRGB, and then CMYK. Even your desktop inkjet printer is a CMYK device. And we'll talk about what makes a CMYK device and what makes an RGB device. So you can see this one on the chromacity diagram on the left, and on the right we can see it represented in a slightly different way. We've got the visible gamut, and then we've got Pantone color gamut, which extends past that RGB in a little spot, but then the RGB catches some areas that Pantone doesn't. And then we've got CMYK in there, which is kind of encapsulated in everything. So we've started the process of kind of what I call cutting the hair. As we're going down in colors, we're losing a little bit each time we cut the hair. If I started out with a Pantone design that the customer supplied to me, and then I'm going to ultimately print it on a CMYK device, and say I pick a color, let me get my highlighter over here so we can do that spotlight. Say I pick a color right in here that fits very well into the Pantone color gamut, it will not reproduce accurately on that CMYK device, because it would have to come down into this area. And I'm going to show you some ways that we can kind of predict what it's going to do, and then we can actually control what it's going to do. So this is just a little overview of gamut. And gamut is the output capabilities of a device. So we'll talk about that in a second as well. And we're not going on to the next slide for some reason. There we go. Next we have RGB, red, green, and blue. And anybody who's played with color wheels as a kid knows how these work. You put them together, and you get red and green, and it makes yellow in there, and then we get the other colors in there. Notice a crossover in all these. When I put red and green together, I get yellow, and blue and green, I get cyan, and then red and blue, I get magenta, CMY. So they kind of cross over into it. Now, RGB is an additive color system, and what that means is as we add them together in the center, we're going to get white. So let me get that pointer again here. We get that white in the center. An RGB device is any device that has light emitting from it. This is your monitor that you're looking at on the computer right now, where you're following along with either the video or the webinar live, your TV at home. Any one of these devices that emit light, a projector would be an RGB device. But they have to have a light source to be an RGB device. Earlier when I was talking about those desktop inkjet printers, sublimation printers is another one for that, sometimes people will call them RGB devices. They are not a true RGB device. To be that type of device, they have to have light emitting, whereas RGB or CMYK devices depend on the substrate that you're going to be printing onto and its white point. So any print type device that uses ink is going to be a CMYK device. So let's go to the next slide. Here's a couple of RGB spaces. Adobe 1998, which is the largest one, considered largest space of RGB out there, and then sRGB. sRGB is what most monitors, TV screens, and everything else are. It is a standard monitor color space that's on the market. Adobe RGB, you can get an Adobe RGB true monitor. They're very expensive. They're a couple $1,000s last time I checked, and I don't have that kind of budget to be able to capture that extra color. If anybody out there is using a RGB capture device, and this would be a digital camera, could even be your cell phone camera, anything that captures like that is an RGB input device. A lot of times, especially in the higher-end digital single-lens reflex cameras, if you go into the menu on it, you can take a look in there, and you can set whether you want it to capture at Adobe 1998 RGB or in sRGB mode. Now, realize every time that we go smaller on this, if I was saying using that camera as an sRGB, this space here is smaller than the Adobe 1998 space. So remember that analogy I used earlier, cutting the hair. Once I cut the hair, I can't put it back. Or once I cut the lawn, for you guys out there, I can't put the lawn back. The ladies seem to go to the hair one a little bit more than the guys. But once we cut that color, it cannot come back. You can add other elements to that design that have a wider color space, but we can't recapture that color. Once I take the picture, it's done. So sRGB is a little bit more widely used throughout the industry. If I go to almost any digital camera, it's going to be sRGB. A lot of your scanners are sRGB unless you've designated it to be in the Adobe RGB. So those are a couple of the spaces. Now we get into CMYK. CMYK color, we have cyan, magenta, and yellow. And in the center we have black, or K. K for black came about because they tried to use B at some point, I suppose, and B was also blue. So they needed a different way to designate that in the offset print industry, and they used K, or key color. That was the key plate that they used in print processes. So when we combine CM and Y, we do get a black color. But to get a true black, we need to add that K channel, or the black channel, to get it in there. And we could go further into GCR and UCR and all these component replacements and how black can add into it and reduce the amount of ink, but that's not the scope of this lecture. And what we're looking to make sure that you guys understand is the difference between RGB and CMYK, and that CMYK is any print process. If there's ink going down onto something, it's using CMYK. So that's where we're concentrating on it. Gamut we talked about a little bit earlier. Like I said, it's not a bad word. Gamut is the output of any device. It's the total range of colors that can be reproduced by a certain device. I touched briefly on some input ones, your camera and your scanner, and output is a monitor, TV set, or printer. The gamut is very important to know and understand. Say like for the roll-in printers that I work with daily, The Roland printers, you can see in here we've got a CMYK gamut, color gamut right there. Their gamut from the Roland inks is larger than a standard CMYK. It'd probably be closer, it's not going to reach the Pantone level here, but it's well outside of the CMYK color gamut all the way around. So say I was doing a design for somebody, and I took that design and I developed it all in CMYK, and then I went to print it on my device. That device, because its gamut or output is larger than the CMYK, which this one we'll call SWOP, which stands for single web offset printing, because it's larger than that area in there, it can reproduce every single color that's inside of it. For CMYK, notice that it's inside the Pantone color gamut, so anything that's within, if I had a design in CMYK and I was reproducing it with Pantone inks and we're screen printing it, I can reproduce every single one of those colors accurately. Now, if I had designed something in the Pantone color palette out here in that design and then went to reproduce it on a CMYK device, it's going to shift in color. It has to come down to the limitations of the print device or the gamut of that print device before it can output it. So that's why we have in there that most workflows go from large gamut input devices to smaller gamut output devices. A lot of people will do their design work in either sRGB or Adobe RGB. I see Pantone a lot out there also, and they're not always keeping in consideration the output of the device. Don't limit yourself, though. A lot of people fall into the trap and they say, I've got a CMYK device, I'm going to design and develop everything in CMYK, which is fine for most vector-type graphics. If I want to accurately reproduce those CMYK colors, I can do it every time with that device. But say I wanted to take a photograph, that picture that I had earlier of the fall foliage, and I want to reproduce it on a CMYK device. If I take that picture and I convert it over now to CMYK, it was taken in the Adobe RGB, this RGB gamut right here, and I convert it over to CMYK, I've taken away a ton of color that I can't get back now. It's better to let the RIP software, or raster image processing software that we'll talk about in a little bit, to have it decide how to shift those colors with a little bit of input from us so we can maximize what we're gaining out of the print device. A trap that a lot of people fall into is they say, well, CMYK, I have to do everything CMYK, I'm going to convert it all to CMYK, and their photographs that they print for sublimation or for the digital print, even inkjet, start looking very washed out and like there's not a lot of vibrant colors when they could be capturing a lot more color in there. So very important to keep those in mind and understand the gamut and what it does. Rendering intents, this is the way we tell that RIP software, that raster image processing. Maybe I'm using VersaWorks for the Roland, or I have the Sawgrass utility for the Sawgrass inks for my dye sublimation, or whatever I'm using for my print process. This is the rendering intent is how we tell it to adjust those colors when output is with a device that is smaller gamut than the color space used. Well, what does that mean? What it means is we're going to tell it, and I'm going to back up a slide. We're going to tell it how to go from here down to the output of that device or the gamut of that device, and how to control not only that color that's outside of it, but everything else within it. So let's take a couple of the different rendering intents, the two most common ones. Perceptual. What perceptual does is it compresses all color and detail into the destination gamut. So anything that's outside of the output of that device, it's going to bring it in to that destination, the output limits of it. And it avoids clipping of colors. What it means by that is it's not going to chop your colors. And I've got a little graphic here that's going to demonstrate that for you. What it's really good for is skin tones and gradients. Anytime I'm looking for a nice smooth skin tone, say across this girl's cheek right here, or I want to make sure that everything's nice and smooth and there's no choppy lines, it hasn't chopped that color at the edge of the destination gamut or output of the device, I want to use this perceptual. So we're going to show a graphic to kind of demonstrate that. So there's perceptual, and then there's relative colorimetric. Relative colorimetric is a one-to-one matching of gamut colors. It says it may clip colors in images, and it's more accurate with vector color matching. Think define sharp edges and contrast. I want to define sharp edge and contrast all the way around here, and we don't want to have any kind of gradient going across that. I don't have to worry about this. This vector graphic is very well defined. Here's my edge right there. There's my edge right here. I need to have that defined. So let me shift over to a graphic that's going going to show you what this means. So here you see that the lab, or what is visible to the human eye. We've got the big outside area right here. And then we'll call this the graphic itself, what its colors are. And this is the gamut of whatever device we're using. And each one of these little dots, like this one here and this one here, they are representative of two different colors that are outside the gamut of this device, or output of that device. So if I tell it to do perceptual, remember perceptual brings everything in, and I always like to think it creates a perceived difference between them. So if I do perceptual and I take this green up at the top here and the green right there, and hopefully everybody can see where I'm highlighting that, because I don't see it on my preview over here. So if you can, please let us know. And I'll click on the perceptual and watch what happens to those two colors. Oh, I guess I got to go off of my highlighter. Click on perceptual, and you see that those two colors, now when they come down to the edge, are two different ones. And then also everything within the gamut of that device also went in. Let's reset that and watch that again. So every color that's in there, when I click on perceptual, it's going to bring them down, and it keeps a perceived difference between those colors. So those skin tones, or the tree colors, and all the different oranges and reds and everything, there's a perceived difference between them, and we don't end up getting a blocky kind of chop. This is the end of the color. Let's take a look at colorimetric. Colorimetric, those two greens there, when I go with that one, you'll see that they come down to the edge. Nothing inside here changed, inside the gamut of the device, but those two colors are now the same exact color at the edge, and there's no perceived difference in between them. And there's no relative difference in between any of the colors on the inside either. So for that vector graph, the bazinga that I had there, it's going to be a very defined edge on each one of those. So for those vector graphics, this is a really nice way to do it, especially because most of the time with vector graphics, I want a defined edge. I'm not looking for smooth, subtle skin tones or anything like that. Whereas with the face, for the girl on there, I want to see those smooth skin tones going across the cheek. I want to see a perceived difference between it. And anybody who's ever gotten a magazine or any print product and taken a look at it, and somebody's face in there, the photograph of whatever movie star or whatever they see on there, is real flat looking. There's no nice gradient skin tone going across there. It's because whatever rendering intent they used was probably colorimetric, and colorimetric did one matching of in-gamut colors, and then it clips everything else on the outside to the edge. So anything on that skin tone that was outside of the output of that device is now right at the edge of that color, and it could show as kind of clipping within the face there. Again, for vector graphics, that's a great way to go. For anything that I do that has photographic skin tones, gradients, or anything like that, I'm going to use perceptual. And that's how we control within our RIP software how to come in. Every RIP software is different. It's going to be somewhere in there, there'll be a color management section, and it's going to allow you to choose whether you want to use colorimetric or perceptual for your rendering intent. You'll need to pick it on your own and find out where that's in there. For those of you that are working with the Roland devices and VersaWorks, I can help you out with that, and you just contact me after the lecture and we'll get you to the right spot. So speaking of that RIP software, what is RIP software? RIP software stands for Raster Image Processor. This is kind of our input-output device. We're taking a graphic and we're putting in there, and we need to tell that printer how to adjust that graphic to be able to print out properly. We need to tell it what temperature to be at. We need to tell it how much ink to put down, how to shift those colors for the white point of the substrate that we're going onto. And we're going to use something called an ICC profile to do that. It's kind of like a recipe. But the RIP software converts that image over to something that your printer can understand and lay down the dots and inks appropriately. So the next portion here is ICC output profiles. ICC stands for Independent Color Consortium. They're kind of a group that has defined colors and has gone through and made some standards for colors that we all can adhere to so that we get consistent output from devices. A profile itself contains the information about the media you're printing on. That information is generated from somebody who makes the profile using the device that's independent of color subjectivity, the spectrophotometer. We're going to measure out ink limits, the white point of the media, as we said before. Dull white paper and something a glossy bright white are going to have two different white points, and it's going to affect how that ink is perceived on there, because most inks are translucent and the white point's going to show through. We do calibration characterization of the output device model, which by that mean we're going to be printing out these different charts and measuring the ink limits. We're going to be measuring different colors. We'll print out known colors and use that spectrophotometer to measure that color that was reproduced from the device and see how it compares to the known color that it was supposed to be. And that way we can tell what the shift is for that specific media that we're printing onto. Now those of you that are doing sublimation may already start to be wondering, well, you know, when I print this out, it changes for every garment that I work on. The white point of this garment is going to be different than the white point of that garment. It can throw a lot of curveballs in your direction, but there are ways to work around that. This is how, the next thing in here, this is how your device knows how to replicate color correctly on the media. What we mean by that is we've given the device a recipe. If I'm going to bake some cookies, I want to have the best recipe out there. If I have just a generic one, they're going to be okay cookies, I would suppose. But if I get a, say, Mrs. Fields recipe, and I'm making these cookies from that, I could have some tremendous cookies. Well, I need a good recipe. I need to know how much ink to lay down, or how much sugar to put in there, how much flour, how many chocolate chips and all that to make a great recipe, how hot to bake it. Same applies for when we're doing a color profile. We need to tell that printer all these different things so that it can reproduce it correctly and to the best of its ability every time. All major reputable media manufacturers and RIP software have these profiles. Most of the manufacturers of medias will provide you with a ICC profile for that print device, for that RIP software, so that you don't have to do it on your own. Now, granted, they're working off of some generalizations. They're measuring on a specific device. They're measuring it with a specific media, and then they're putting that out to you. And if you use that same device and that same media, you should get very consistent results. The only way to truly dial it in is to do it on your own end, which is a bit more complicated and more costly. But if you're using from a reputable manufacturer on the media side and on the ink side, they're going to provide you with the correct ICC profiles. Where a lot of people fall into this trap is they just go with the generics across the board. Well, I don't know what this is, so I'm going to use generic. The right answer is to go back to the manufacturer and say, hey, I'm using your media. I need an ICC profile for this for my software, for my RIP and my device, to be able to make sure that I get the best color output from that possible. So let's take a look inside a profile. What does a profile do? A profile is going to have a source that comes in. That's your graphic, whether it's RGB or CMYK, and it's going to take a look at that source and kind of dissect, is it RGB, CMYK, Pantone, do I have some lab values, what color do I have in this? And most RIP softwares can look at multiple inputs from that graphic. So if I have a graphic I've designed in CorelDRAW, and it's got an RGB color in there for one part of the graphic, it's got a Pantone color in there for another portion, and I've got CMYK or whatever else, it can identify all those different sources within it and sort them out correctly. What it's going to do with each one of those individual sources is it's going to process it over to a lab value. If you remember from the beginning of this webinar, we talked about lab values and that it's a scientific value that we know exactly where in this space here, in this lab space, that value is. And I can translate it over to any other device and say, this is the lab value. You need to reproduce from that lab value and have an output based off of that. So from that lab value, we had our source, took the colors, made a lab value. Now it's going over to a lab value at the destination, which the profile is going to do a conversion to bring it over to what the destination needs to be based on the media that I'm using, the inks that we're running with, the model of printer, and all these other variables in there. And it's going to take it to an output for that device that's a CMYK value that is the closest possible match based on how we told it to work. If I told it to do a perceptual rendering, if I told it to do a colorimetric rendering, and we've told it to convert this properly. So really what the ICC profile does is it's the conversion process. It's taking it from this graphic and taking the colors from that, identifying what each and every one of them are, and then sending it over to the output device with the closest possible match with that color. So the profile really does this conversion process for us. Without it, you're going to get mediocre color at the best. It's very important to make sure, and I can't stress it enough, that you have the right ICC profiles for what you're printing and what you're making, and that they're correct for your machine and your RIP software. Direct to garment, you need to make sure you have the right ICC profiles. Sublimation, large format, all of them. If you don't have a good ICC profile, it's not going to print properly. Now, some of them they all have generic profiles, and then some of them will have a vendor-supplied one. And I keep going back to the rolling because that's one that I use the most. And maybe where I've got a decal material that I'm going to print onto with one of these rolling printers, and I don't have a specific profile from that manufacturer. I can take a general, not a generic one, a general profile within that RIP, say for that one glossy calendared vinyl, and take that as a starting point. I can print onto that and I can take a look, did this print properly? Are my colors accurate to a certain point? Do I need to shift anything? Do I need to maybe try a different profile and see if they come out a little bit better? You can start with that if the manufacturer doesn't have a profile, but I would always recommend going back to the manufacturer and asking them for a correct profile. And some of them may tell you, use this one that's within your RIP software. That will do the best for you. So that's a little bit of a look inside the ICC profile. Custom ICC profiles, like I said, the canned profiles have information about the device that's the same model as yours, but not your device. I could take two VersaCams and put them side by side. They're both, say, a VS300, and I use the same exact profile, the same exact medium between them, and I could have slight variances in between those. That just has to do with the print head itself and the technology. They're not going to be identical down the line. Two of them rolling off of the line side by side can have a slight shift between them. It's not going to be a major shift. It could be slight variations. The only way to truly get each and every one of those dialed in so they are producing the exact same output every time in between all those devices is if I had one of those spectrophotometers and I made profiles for each one of those to match to the output. So I would need to get that software and that device. That's expensive. It's very expensive. To get the spectrophotometer itself, you're talking about $1,000. To get the spectrophotometer and the accompanying software to be able to create profiles, it's about $2,000. That's not something every shop is going to do. That's usually slated for the shops that are doing very specific print processes, and they have customers lined up that need a specific color on the output, and they need to make sure all of their devices are consistent. I would say generally about 85 to 90% of the time, the customers that I've come into are very good with the manufacturer, the media manufacturer supplied profiles. They're very happy with the results, and sometimes they have to tweak it in a little bit. But other than that, they're not looking to have the devices to be able to make it themselves. The ones that are up to a different level, well, they can justify the cost at that point. And the last line on here, custom ICC profiles, when done right, will outperform canned profiles. That's a no-brainer. If I'm going to dial it out of my, say I took a generic cookie recipe and I'm going to make it specific to my oven, my ingredients, and everything else, obviously I'm going to get a better output from that than I would from using the generic canned ones that I get. So that one kind of goes pretty easily. Defining the print environment, what we're talking about here is this is all that goes into an ICC profile. When someone like myself, and I do create ICC profiles for the roll-ins, we have to take into consideration all these different things, the brand of printer, what model it is, how the print head operates, is it a DX4, 6A, whatever print head that we've got in there, the heater settings, the calibrations on the device. We run a full set of calibrations on it. If I'm looking at a profile that somebody else has made, did they properly calibrate that machine before they started the whole print process? Then we take a look at the media itself and how it absorbs ink, what's the white point of it, and then we have to get into the RIP settings and look at the print mode, ink limits, linearization curves, total ink limit. There's quite a bit that goes into defining that print environment. Thankfully for everybody here, we've got a lot of manufacturers out there that have done all this for you. Or they'll send it out to somebody who will do it for them, and then they provide the end product, that ICC profile, to you. So your job is easier. What you really need to do, and I keep saying it over and over, go back to the manufacturer, the media manufacturer or your ink manufacturer, and make sure you get the right profiles. That alone will set you apart from your competition. That and understanding the difference between CMYK and RGB and how we design and work with. Personally, with CMYK and RGB, I design almost everything I do in Adobe RGB, which is the largest color spectrum that I can work with there, other than the lab, and I'm going to dial it in based on what my output is going to be, what I want to come out of the printer. And I'll let the RIP software, back up a second, do this conversion for me from that RGB down to a lab value that I know it can take that lab value and give me a destination and give me a proper output for it. So, what about color matching? Customer comes in and they say, you know, I'm looking for red. I need red on this, and it has to be exact on it. Well, are they talking Coca-Cola red, fire engine red, brick red, and are they seeing red the same way I am? Well, with color matching, some RIP softwares have color charts that you can print. I see this a lot with the sublimation printers. All large format digital printers that I've run into have a color chart that you can print out. And once you print this out, you could take that color chart, I think I got an example here. I could take that color chart and hold it up for the customer, and they could point to the color they wanted. Hey, this is the color I want. Now, it's important that when I print this chart, that I print it correctly. And you'll have to go back to your RIP software and take a look at how it tells you to print it. Most of them are going to have you print it a specific way. For the roll-ins, you have to have your density control only set on your color management when you do the chart. If I don't have that set, it's not going to print the chart correctly. And then when I go through the color matching system within that RIP software, I'm not going to get the right output from my device. It's not going to match that chart there. So it's very important that you learn with your specific RIP software how to do that and use consistent color management. If it tells me that I have to use density control every time on my color management, well, then I'm going to use that every time if I'm trying to match up this chart. For the roll-ins, you just have to do it when you're setting up the chart, not when you're doing your output. Now, say I want a step further, and I'm going to create my own color chart. I'm going to take a whole bunch of red colors, and I'm going to line them all up on there, and this is my red selections for the customer, and I make a chart from it, and they can pick off of that, which is fine, but I need to make sure that I use the same color management every time. With the RIP software controlling it, if it's got a chart that you can print out, generally it has a system in place so that if you've named the color a specific way, it's going to recognize that color, and it will disregard any other color management and reproduce it identical to the output chart every single time. If I've created my own chart and bypassed what the RIP software has in place, now I need to make sure that I have consistent workflow, and I need to stick to it. If I don't do the same exact settings as I did when I created that chart, I could have color shift because maybe I'm using perceptual versus colorimetric rendering, and it's bringing the colors in differently, so it could shift. So creating your own color chart can work. You just need to really make sure that you have consistent workflow and that you keep it the same every time. Now, I have under this one, different substrates will appear to shift colors, and what I mean by that is the white point. Go back to the paper analogy that I keep using, a bright white glossy versus just a regular lined paper that's got a duller finish to it, more bluish finish. They're going to shift on the color. So whenever I'm making one of these color charts, I need to make sure that the color chart is printed on the substrate that I'm going to be using. Sublimation printers, I keep coming back to you guys. What this means to you is picking probably a medium grade white shirt that is the general use one in your shop, creating your color chart, then heat pressing it to that substrate so you can see what the colors are going to be on that substrate every time. Realizing that if now I shift to a light gray shirt, it's going to shift those colors quite a bit. Regardless of whether I'm using the RIP software color chart or I've created my own color chart, that's the true way to get a chart with sublimation that you're going to be able to match up to every time. I could hold up that shirt and the customer could say, that's the color I want right there. And you know that this shirt has, if not the same, a very similar white point to the shirts that you're going to be using, and you'll know that you're going to get consistent workflow out of it, and you're going to get consistent colors. The last thing I have on here is use a Pantone to CMYK bridge. I see this one a lot where somebody will come in and they'll say, I want Pantone 432C. And I don't know if my device is going to be able to reproduce that or not. Maybe that Pantone color is outside of the CMYK gamut of the machine. The gamut was the output of the machine, what it can physically reproduce. Even with the ink set that I've got a larger gamut than CMYK swap, it may not be able to reproduce that Pantone color because it was well outside of the range of it. Well, using this bridge here, there's two colors on it. On one side it'll have a color, and on the other side that's a Pantone color, and on the other side right next to it it'll have what it would reproduce as if I used CMYK single web offset printing, if I use that color space. And now I could take that to the customer and he says, I need 432C coded Pantone color. And I can say, okay, here's my color bridge. Let's take a look at it. And on the left-hand side, it's a 432, and on the right-hand side, this is what will come out if I use CMYK from my CMYK device. And he may look at that and say, wow, that is not acceptable. That color is very much off and will not work for what we're trying to output here. Well, then you could go back to the color chart that you created, and you could say, well, let's pick a different color. Instead of using Pantone, maybe I'll use the color chart that my RIB software had, and we could pick it off of there. And maybe your color, we'll take that swatch and hold it up to there, and we find one on there that's very close to what you want, or close enough that the customer's happy. This doesn't always happen. When somebody comes into the shop and says, I need red, they have an idea in their head, and it's so much easier to hold up that color chart and say, you pick. Or hold up that shirt that's been dye sublimated and say, you pick. And they pick the red off of there. Or if you're using a direct-to-garment, you can still make a color chart and print it onto there. And then once they've picked it out, you're going to get very consistent color matching to that. And that's the approach I take most of the time. Is if somebody's specific and they want a color, I'll hold up the chart, you pick it, and we'll reproduce it every time for you. The CMYK bridge, that comes in real handy when you're maybe dealing with an internet customer or somebody on the phone and they say, this is our color. And I can take a look at that real quick and tell whether or not it's going to hit it, and then possibly give them some other opportunities on that. So it's another device that you can get. My personal is I'll go with the color chart that's reproduced from the RIP software. If that one doesn't work, then I can go into a color chart that I've created my own, or possibly the Pantone one. So we've got a number of different options. A lot of times, too, if I have a real picky customer that's just wants to dial in the color that drastically, I'll print a proof for them, but we always charge for the proof, because if you do a proof and you didn't charge for it, well, you might just lose the whole job, and how much work did you put into it? So a smart way of doing it is to make sure that you at least capture something for your work, and what we do a lot of times is we'll deduct it from the actual order. So now the customer is kind of locked in with you to a certain extent. You've built up a relationship at that point. Another way to capture color, that spectrophotometer, if anybody does get into that and wants one of those, most RIP softwares will have the ability for that spectrophotometer to read a color. So if somebody comes in and says, hey, this red that I have right here on this dress, this is the red that we need to match. You could take that spectrophotometer and have it read the color from that swatch, and then it will input into the RIP software, and it will tell you if it's able to reproduce it, or it will use whatever color rendering that you told it to, and it will reproduce the closest physical match using the inkset and limitations or gamut of that machine possible. So that's a little bit more advanced way of doing it, and you can do that. That's kind of like in Home Depot, that wall of paint that I was talking about. If anybody's seen the commercial where they bring in the stuffed purple dragon and they stick it in a little color matcher, that's a spectrophotometer that they've got there, and it's measuring the color off of that whatever swatch or sample they put in there, and then it's coming up with an ink configuration that they'll be able to reproduce to get the closest possible match to it. Same concept, they're just doing it with paint, and we're doing it with ink out of a printer. So, and some recommendations before we get into a little question and answer for everybody. Always use known color space data for the file. What we mean by that is, if I get a file from somebody, I get a design from them, and they're real picky about color, I'm going to want to know where they created that in. And most of the design software out there, Adobe Illustrator, Corel Draw, you can set it up so that it will tell you if the color that you have coming in with whatever you're importing in graphic-wise is a different color space than what you're set up for in that design software. So typically, like I said, I use Adobe RGB 1998. If I've gotten a graphic from somebody and I bring it in there, it'll pop up and it'll warn me. It'll say, hey, the graphic you're bringing in is sRGB. Do you want to maintain it as sRGB? Do you want to try to convert it over to Adobe RGB, which we know won't be good because it's just assigning colors outside of a color area that it had is kind of hit or miss. It's not going to work properly. But it'll warn me about that. So I want to know what that is. if somebody provides me with a photograph, I'm not just going to assume that it's sRGB. I'm going to take a look and try to find out to get the best color reproduction possible. It's not always possible to do this. Somebody brought you a photograph that was right-clicked and saved from Facebook. They're not going to know what color space that is. On those types of projects, I generally, myself, will make the assumption, I know we all know what that means, that it was done in sRGB. Because if it was from a digital camera, it was either set to sRGB, or if it was a professional photographer and they used Adobe RGB, I'm safe in knowing that all the colors in sRGB will be able to be reproduced. So always use a correct media profile for the printer, ink, media, in combination what you're using. Can't stress that one enough. Without the correct profile, yeah, you're just sending ink to the media, and you're not going to get consistent results, and your colors are not going to come out anywhere what you want. Calibrate your monitor. If you have the ability, calibrate your monitor. You can get a device called a Color Monkey. It's a little thing that hangs on the monitor and does a quick calibration for you. It's a great tool to have, and that allows you to get the closest representation on your monitor to what that color actually is. Now, everybody's probably run into this before, where you've got a Joe customer on the line, and they're saying, hey, I'm looking at this proof on my screen, and it doesn't look blue to me. It looks purple. Well, their monitor's probably not calibrated, and they may be looking at a color that is shifted on their monitor because they're in a different light, or their light source from the monitor itself is not set correctly. That's where you get back into creating a physical proof for the customer, or like we were talking about before, when they chose their colors, you pick it from the chart. And that way I know I can reproduce accurately every single time. That chip chart led me right into it. Use a chip chart for easy spot color matching. With that chip chart, I know I can hit that same color every time on that same exact substrate. Is it feasible for me with a large format digital printer to print on my wall graphic material, my decal material, a cast decal material, all of my different heat transfer materials, and have all these color charts hanging out? No, it's not. It's just not. That is a recommended way to go, absolutely, but it's too costly and too wasteful in my eyes. What I'll do is I'll pick one that has a medium white point as compared to all the rest of them. And maybe if I have a product that they use all the time, like for heat transfers for me, it's Quick Print that I use the most of. So I'll print out that chart on Quick Print so I have that as a reference at any time. And then I'll do one of my decal vinyls so I have a couple to go from for the customer, and I can tailor to them. But having it for each and every substrate I do just isn't cost effective. And last but not least, know your limitations. You've got to know that I'm not going to hit every single color that's out there. Somebody comes in with a Pantone swatch and this is what we want to hit. It's not going to happen all the time. If it's within the gamut or output of the device, then I'm going to be able to hit it. If it's outside, we are going to have some color shift. Understand those limitations and be able to tell it to your customers. Be able to demonstrate it to them. And you're going to have a superior output every time. Now, knowing all these things, having that color matching chart, having your substrates dialed in, using the correct ICC profiles, understanding the difference between RGB and CMYK, you're going to be well ahead of your competition. Don't say it's just a CMYK printer, that's all it can do, because it can do much more than that. And we can get very, very beautiful, vibrant color reproduction with that, with some known limitations. But anytime I hear somebody say at one of the shows, well, it's a CMYK device, you're not going to get great color out of that. I'll point to all the different things that are in the trade show all over the place and say almost every single one of these was done with a CMYK printer. And they all look pretty darn good to me. So we can do it. We just need to understand how to do it properly and know our limitations. So that's my last slide. We've got a few minutes here. Jody, do we have any questions out there right now?
Great presentation, Stephen. We do have one question. April would like to know, are they making profiles for the VS300 yet?
April, I'm glad to see you here. There are some profiles for the VS300 printer. They're on myversacam.com. If there's a specific media that you don't have a profile for, I do a lot of those. So if it's a media that we have at Imprintables Warehouse, I can make those profiles for you. If it's something that we don't have at Imprintables Warehouse, I can help you dial in with a different manufacturer. If the manufacturer doesn't provide that, we can look into finding one that will work best for you. There are more and more manufacturers out there. The VS it's not real new, but it's still fairly new to the market. There's a lot of manufacturers that haven't caught up and haven't created profiles for it. So I am seeing more and more out there. So April, shoot me an email and let me know which specific media you're looking for. And if I can, I'll get that for you. If not, we'll see a way if we can dial it in, all right? And no other questions?
Well, just one more. Kathy wanted to know if we can have copies of your slides, or at least some of those with the definitions. And
yes, absolutely.
And when we do post the blog, I will post it as a PDF as well. So we'll have a PDF version of the slides available to you.
Okay, yeah. I can send that over to you. You just need the slides, right?
Yeah.
Sure, absolutely.
And the blog will be posted within the next 48 hours. And for those of you that would like to re-watch this presentation, you could either hit it up in the blog, or it will always be available in our archives as well. Excellent. And Bob wanted you to know that he loved this presentation. You did a great job.
Thanks, Bob. I appreciate it. I want everybody to know color's a really tough subject. Every time I teach it in the workshop that I do, I talk about the light bulb effect, where I look around the room at people and they've got the head tilted to the side. They don't quite have that light bulb. And as we go through the lecture, I hopefully see the light bulb go on for everybody. And I know it's one of those that you can come back to several times before you really sink in and eat it. We went through a lot of information here in less than an hour. So if you have any questions or specific thing that I can maybe develop on or create another video or some other resource for us, please email me, steven@imprintables.com. Let me know, and I will do my best to get that out quickly to everybody. We are looking at developing some more color management and color theory lectures and webinars in the future, so your input will help us with that. So I appreciate everybody coming by. Anything else from your end, Jody?
Nope. The blog address to access the blog, you can find it at www.greatgarmentgraphics.com/blog, or in the upper right-hand menu, you can just click on the blog and you'll be able to find it there by Thursday. So thank you so much for joining us, Stephen.
Oh, my pleasure. And like I said, let us know what we can do in the future for color. And I want to thank everybody for taking time out of their afternoon and joining us today. And hopefully we'll see you guys at the next webinar. Thanks for stopping by.